morning, dear students. Today we are going to solve a problem on modal analysis. A simple modal analysis of a cantilever beam as shown in below. Objective is to get the frequency and different modes of vibration. Now, say if you want to solve this problem, is given Young's modulus 2e to the power 11 Newton per meter square. I value is given, that is 8.33 e to the power minus 6 meter to the power 4. If not given, also based on your cross section area given here 0.1 into 0.1, we know that for rectangular cross section how to calculate I, that is bh cube by 12, you can calculate it. Now area will be 0.01, that also you can calculate it. If not given, 0.1 into 0.1 cross section area is given, you can calculate it. Then density of the material is given, that is 7830 kg per meter cube. Now how to determine this? How to determine your frequency and your mode shapes? Now first I will show how to solve it in theoretically. Now just see here, this is what the given data. Length is given 1 meter, breadth 0.1 meter, depth is given, Young's modulus is given, density is given. Density here they are written as a 7.30 kg per meter cube, that is 7.83 in 10 power 3. Then acceleration due to gravity. Okay, acceleration due to gravity 9.81. Now pi value we know that. Area you know how to calculate. I think all these things are given. I is given. Okay, now density you should take it here, surface density. How to calculate this density? See, density divided by G, you are going to get it 7.982 e into 10 power 2, that is kg second square meter to the power 4. You have, see, if density is given divided by G, this density you should use for your modal analysis. Okay, not only for modal analysis. If you are doing in a your dynamic analysis, you should always consider your this density. That means whatever density is given divided by acceleration due to gravity. Now, how to solve it theoretically? See, beam constants. If you refer some textbooks, you can get this. Beam constants are B1 I1 whole square, B2 I2 whole square, B3 I2 whole square, that is 3.52, 22, 61.70. Now circular frequency, the formula is omega n1 equals to, this is the formula what you are going to get it. So if you substitute all the values, above values, you can get like this 1.608 e into 10 power 3. Like this you are going to get a 3 values, omega n1, omega n2, omega n3. The meaning of omega n1, n2, n3 is, here we are going to determine 3 frequencies. Now how to calculate omega n1, omega n2, you are going to get like this. Then how to calculate your fn1, that is in terms of hertz. Okay, we know that omega by 2 pi. Using that you will calculate it. That is 255.89 hertz, 1599 hertz, 4485 hertz. This is what the values you are got it for this theoretically. Now how to solve this problem in your answers? Now I will show. I am going to minimize this. Now I will use your answers first. I will open answers. Now go to preferences. Now structural. Okay. Now take your preprocessor, element type, add, delete, add. What is your element type? Go to beam because it is a beam problem. 2D elastic 3. Give OK. Now close this. Now after closing this, go to next step, real constants, add, delete, add. Okay. Now see, just observe what are the values you should give it. Area you know that what is that area? 0.01. 0.01, is it correct? Just check it here. If you go here, see 0.01, correct? Then what is your I value? See, just blink here. See, what is your I value? That is IZZ 8.33. If you have any doubt, just go here, 8.33 e to the power minus 6, e to the power minus 0.6. Okay, e to the power minus 0.6. Okay, height is 0.1. This is what the given value is. Just give it, give OK. Okay, close it. Then after this, next thing you should go for material properties. Go to material models. Okay, structural, linear, elastic, isotropic. Now what is the Young's modulus given? 2E11 is given. Just give Young's modulus 2E11. Okay. The your Poisson's ratio is not given. For 1D it is not required. Give OK. Just give OK. No problem. It will last 0. No problem. Give OK. Then one more thing is density you should give. Density I told you it should be your, so you should use your this density. What is that? Surface density, that is 7.98 into 2 into 10 to power 2. That means I can give like this here, 7.982 7.982 E2. Okay, give OK. Now material, exit. Now open answers. Yeah. Now material models is given. Then what is the next step? Go to modeling, create. Okay. Now here, create it in key points. Say I want to mesh it because I want a smooth curve and smooth mode shapes. For that purpose, I will go for a key points in active CS. Okay. Now first key point I am creating at 0. Next I am creating one more key point, that is length is given, that is 1 meter. Okay, give OK. Then after this, go to next lines, straight line, click 1 and 2, create it. Now line is created. Minimize this, minimize this. Next, go to the next step. See, after creating line, go to your next step is meshing, because you have created line and key point and line. What we require generally node and element. If you want to tell it as a finite element model, it should be in the form of a node and element. Now how to convert it? Go to size controls, manual size, lines, picked lines. This is your picked line. Now decide how many number of elements you require. If you want a smooth, you can make it on 25 elements, no problem. Okay, 25 elements I created. Now minimize this, go to mesh, lines. Now pick this lines, give OK. Now it has been meshed. Now after meshing it, what is the next thing? Go for giving boundary conditions. Solution, see, define loads, apply, structural. Now we know displacement. We know what is only on displacement. Displacement on nodes or key points. You can use key points. Okay, click this key point, or you can use node also, no problem. All degree of freedom. Node or key point. I think key point has been converted to node, no problem. Now click it this, minimize this, minimize this. But here, after applying load, you cannot solve the problem directly, because here you are not doing a normal analysis. See, always if you go for analysis type, default always it will be static. Okay, but what if we are doing in a different type of analysis? What type of analysis we are doing? We are going for a modal analysis. Now click modal, give modal OK. Now see here, options has been changed. Now go to analysis options. Here use a method. There are different methods are there. I am choosing Black-Lanczos method only. Now how many modes I want to extract? See there you are given 3 values, correct? 3 theoretical values you are given. Now I am checking only 3 only. I am checking. I am giving only 3. Now 3 modes I want to expand. See, I want to extract 3 modes. Then I want to expand 3 modes. Now give OK. Now it will comes here. Say fix the frequency. I am not going to fix the frequency. Give the mode shapes. Okay. Okay. Now close it. See, now analysis type is given. I had given your boundary condition, everything. Then go for solving the problem. Solve current load step. Okay. Now see, solution is done. Close this. Close this. Now minimize this. Go to general post processor. Plot results. Before going for plot results, first go for your read results. Click last set. Okay, just to ensure all the values should be there. Okay, now if you want to check your frequency, go to your result summary. Just observe here, result summary. Are you seeing the frequencies? 255.16, 1580.9, 3958.0. Now similar, if you want to compare these values with theoretically, just observe theoretically. See, almost similar values, 255, 1599, but 4485. I think last value we are getting little bit of more difference, but first two values are almost same. Okay, this is how you can check your theoretical answer and your analysis answer. Now minimize this. Okay, minimize this. Now I have seen the order of frequencies. Okay, 3 frequencies. But how to see these results? Okay, go to plot results, contour plot. Okay, no contour plot. Before that, go to plot controls, style, size and shape. Just display of element you can switch on. You can see the better element. Okay, keep it in 3D mode. Okay, now you want to see the oscillation of it. Now go to your deform shape. Okay, now cancel this. Now go to your read results. Now first set. Now go to then plot results, deform shape, deform plus undeform shape. See, this is what your first mode. See, what is the frequency? 255.16. Now if you want to see next set, what is the results of next set? Go to read results, click next set. Okay, click next set. Now after this, go to here plot. See, just bring your cursor onto screen, just plot, replot. Now you are observing the second mode. Now if you want to see third mode, just go to read results. Now next set. That means what is your third set? Now plot, replot. Now see, this is your third mode. See, you can observe that all the different modes of frequencies. Now I'll just, if you want first set, go to first set. Now plot, replot. This is your first set. Now if you want to observe how the body is oscillating, because generally you will see it is like a deflection, correct? But how the body is oscillating. So if you want to observe that, go to plot controls, style. Okay, there is a animate. Go to plot controls, animate, mode shape. Okay, here you can give deform plus undeform shape. If you want both, you can keep it, no problem. Or only deform shape also you can keep it. Now I am keeping both deform plus undeform shape. Just give OK. Now you can observe this. This is how the body is oscillating. Now if you want a little bit faster, I will reduce the frame. Okay. Now this is how the body is oscillating. Similarly, you can do for different modes also. This is the first mode I done. This will be repeated for second mode and third mode also. This is how you can solve your mode analysis problem, and this is how you can check your results. Okay, this is how you can see your result summary. Okay, now thank you.